Hey everybody, welcome to Learn with Mage. I just want to give everyone a couple more minutes to get logged in, and we can go ahead and get started. But we'll be on in about 1 to 2 more minutes. Hey everybody, so let's go ahead and get started. I know we haven't, Mage hasn't done one of these Learn with Mages in a while, but we have a super cool session in store for you today. And we are going to learn about how Librenergy developed an AI-ready data workflow for battery diagnostics. And today I have Fred Revolier with me today, who spent the last 25 years doing engineering work, 10 in industrial automation controls and robotics. And then the last 15 years, he's been in renewables across utility scale solar and battery storage. So Fred recently founded Librenergy, solutions to bring purpose-built data platforms and performance engineering services to energy storage operators. This really blends his controls background with modern data tooling like Mage and ClickHouse. Welcome to Learn with Mage, Fred. How are you doing today?
Yeah, great. Thanks for having me, and thanks for kind of letting me share my experience with your audience.
Yeah, sure. So let's go ahead and jump right in. So why don't you tell us just a little bit about Librenergy and the problem you set out to solve for your customers?
Yeah, so we're going to talk about how we address kind of performance issues with large battery energy storage system that we refer to as BESS.
Sure.
And think of this as like big power plants that the energy source is a lithium-ion battery. But not just a single battery. It's like hundreds of thousands of batteries sometimes. So Librenergy, we focus on performance engineering of these assets. And we do two things. The first aspect is to build data platform for the owners and operators of these assets to
Okay.
collect all the data from the equipment, and then just can use modern kind of data engineering tooling to be able to run analytical kind of workload. So empower like the data analyst and performance engineers to kind of monitor data, run analysis, and things like this. And we build all this based on open source tooling, and Mage is a big part of it to run ETL pipelines and then also run kind of all the data analytics kind of automation.
Yeah, sure. So you kind of touched on like just an intro to the kind of the landscape of what your clients are using in terms of tools. But what did that kind of look like before you came along and helped your customers?
So these sites are like remote sites with like a local kind of data acquisition system. So really, before we came along, the owners of these sites would have to maybe VPN into the site and log into a web interface where they could have access to like a screen where they could monitor their assets performance, look at KPIs, look at time series charts, and maybe download data to a CSV file. But these sites data acquisition system are not really designed for running like queries on it or analytical kind of payloads. So a lot of kind of data transfer and manual operations. A lot of people download spreadsheets and then run their monthly kind of KPIs on this. And then there's also multiple data sources. There's data coming from these battery assets, but there's also data coming from the market. Maybe the way you traded the energy, your settlement data. So you have to kind of aggregate all this kind of manually. So we let them all do this into one platform.
Okay, that's awesome to hear. So you kind of talked about what it looked like before. Now, can you kind of give us an idea about some of the tools you're currently using? I know you're using Mage, but maybe go into some of the methods you use to kind of solve those problems that you were seeing.
Sure. I'm going to share my screen here.
Okay.
So this is a simplified view of our kind of data stack where the core data warehouse that we use is ClickHouse. ClickHouse is a great blend of time series database and OLAP. You could run analytical payload pretty efficiently. So we use this as the core database. And then for everything ETL, we use Mage. And we also use Mage, different instances of Mage to run analytical payloads. These assets are obviously they're connected to the electrical grid. There's really a lot of cybersecurity concerns about them. So they're not connected to the internet from there's no way for us to, from the cloud, access directly the assets. We have to have secured VPN tunnel. So
Okay.
we run Mage into a kind of an AWS VPC that would have a VPN tunnel to the site. So the Mage instance that's pulling the data will be kind of close tied to the data source on site.
And so we've kind of chatted about this before, but this is kind of the reason you chose an open source tool. Is that correct?
That's correct. That's why we're running Mage open source, and we run it on our own, like a Docker Swarm cluster.
Okay.
That's part of this kind of secured network.
Yeah. So can you kind of maybe talk about what other tools you considered in replacement for Mage? I know we chatted about you're using the open source and you made that decision, but what other tools did you kind of look at?
So I'm fairly new to data engineering. It's been a couple of years. So when I really kind of dived in to this landscape of data engineering, which is kind of fascinating, I looked at things like Airflow and Prefect and all the tools out there. But that was at the time where Mage was doing a huge push. So I've been a long-term kind of user of Mage probably for a couple of years now, since can't remember the version numbers, but it's been a while.
Okay.
And I kind of, with this entire data stack, I really wanted to stay away from Java. I wanted to standardize on things that speak SQL and Python across the board. So Mage was like kind of the perfect tool where it's all written in Python. You can extend it. And then it was for me as a new kind of data engineer, it was actually quite easy to understand how it works. I had some experience in writing Python notebooks and running Python, so the whole kind of experience with the UI, everything felt pretty good. So
Sure.
I've been using this in production for quite a while now, and it's been very, very robust.
Yeah, and so something I just kind of wanted to get in was that Mage obviously has their open source platform, but we also have Mage Pro as well that can be deployed on-prem. So you could theoretically solve this solution, solve this kind of VPN gap issue with both both open source and Mage Pro being offered into like on-prem deployment. But I really wanted to move on to more of the meat of this chat, and it's really, we wanted to talk about AI-ready data. Mage kind of refers to AI-ready data as timely, reliable, and relevant. So before any AI could run, you had to get the data in shape. And this is really what we're referring to as reliable data. So what was kind of the foundation building process? What did that look like in terms of getting your data ready and reliable for your AI use case?
So I think the key here for us was really the data model around pulling all this sensor data. So if you think of what's coming from the sites here, it's just a time series, like a sensor ID, a timestamp, and a value.
Sure.
And we're talking about like 200 to 300,000 data points a minute.
Okay.
Individual data points that all come in a big table. So the main thing is like for us was to create a robust data model. Let me see if I can advance this. Building a robust data model, kind of context of how the plants are configured, their relationship between all the site devices, and then documenting all the sensors kind of types, categorizing things. So at a high level, these plants have, there is the plant, the BESS, and then there is blocks of power conversion system and then batteries. And then within the batteries, there's other devices, and all this have a bunch of sensors. So first is to build a kind of dimensional star schema kind of model of all the potential sensor data, their types. So we have sources of data, we have devices we call segments. This could be physical device or maybe market data. And then each of them have measurements and logs. So measurements are like matrix, and then events more like your logs. And we categorize all of them into certain data types. So when the AI agent or even a dashboard, when we want to run a query, and let's say we want to look at the power of all the power conversion systems, then we can look for power across like all the PCS, for example. So that aspect, building this dimensional model is pretty key. And then building a strong taxonomy around how we're going to name things is also super important. So we have a clear taxonomy of how we lay out the segment names across the entire data points. This is not very big here, but let me just zoom in here. So it kind of looks like this. You got a tree view of all your devices. And that's pretty typical, I guess, for IoT devices. And this context here, we're able to give it to any AI agent, really. So ClickHouse has very good support for connecting an AI model, kind of large language model to it through MCP. So it's very easy for us to give context to an LLM about how this is structured, and for this LLM to go query these dimension tables and understand the data that's available and how it's structured. So I think that's really the key part, is to be able to define this context fairly simplistically and have it kind of uniform across different sites and different kind of projects.
Okay. Yeah, you kind of covered one of my questions about why you chose ClickHouse, but are there any other reasons that you made that choice, that it was a good fit for your use case?
Well, ClickHouse was kind of the closest to a time series database. So it's there is like purpose-built time series database like Influx and I don't know, Canary, but these are not, they're typically not SQL compliant. So I wanted something that was SQL compliant and also kind of fast, that could be used, so you could push in hundreds of thousands of kind of data points per minute. And ClickHouse has kind of rise to be like the kind of the best database for this. It's used for observability, by pretty much everyone in the industry, millions of data points per second. So, and then they've also kind of really embraced the AI. So they were pretty quick to release an MCP server. It's been out for over a year now. They've made some acquisition around AI and observability. So really what we do here with IoT devices very similar to what you would do with like metrics and logs on a data kind of a data center or whatever, like your infrastructure. So
Okay, that's awesome. So how do you think about the relationship between data quality, so how reliable your data is, and what AI can do with it downstream? So really, like, what's your take on that reliability aspect of AI ready data?
so we found that I guess the AI agents are pretty resilient to data quality problems. If something is wrong, they will kind of find their way around it. So we're actually not so worried about data quality. We make sure we run some quality checks to make sure there's no data, the missing data. But then the when we do our analysis, this is where we would have some kind of some guardrails on how certain things should look, more like on the when we process the data, not really too much how when we ingest it. So we found the AI agent in general to be quite good with data, like data quality problems. Not that we have too many, but
That's pretty interesting to hear. Next, I kind of want to talk about, kind of your use case. So, can you walk us through like the autonomous battery diagnostics pipeline you have, and what happens from like the moment data comes in to when a report lands in someone's inbox, or you are analyzing this and whatever your analytics platform is. I'm not sure if it's Grafana or something else.
yeah. So the unlock here has really been like the I guess the agent skills, and so the whole kind of the way we really implemented this is that first we started by giving access to engineers, performance engineers that have to go and do diagnostic on some of this issue, give them access to Cloud Code on their machine, on their local machine, and give them access to the ClickHouse database, and then some base kind of skills explaining the context of the data and how to query it. We also use Notion as our project management tool. So being able to kind of, dig into the data with your like chatting with Cloud Code, and then maybe updating your tasks or your reports automatically, really unlock kind of the users exploring and then creating kind of this workflow. And for the past, I don't know, 6-8 months, you can actually create a skill in those AI agent that kind of document the entire process that you went through and what the agent did. It's kind of just a stand like an instruction document for the agents. So what we do is we have the performance engineers go through different use cases. So maybe they need to look at faults on the equipment, or like state of charge balancing on the batteries. They will just run everything on their local machine in a specific folder that we actually have as a Git repo. So like the configuration to the MCP servers, the skills, everything is baked into this one folder. And then they just kind of use this to automate their day-to-day work. And then once they get a skill, kind of a repeatable way to do this that could take days or a couple of days or a week, then we push it to Mage to automate it. And I could show you kind of how this looks like quickly. So it's fairly straightforward. It's like, this is actually what we call our performance engineering repo,
Okay.
where this is repeatable from machine to machine. So my engineer can run this, I can run this, and it's just I can run the same kind of skills and then access the same systems. in the Claude folder, we have a bunch of skills that define different processes that we do. So here, for example, there's one about PCS communication faults. And you would have just a long description of what the agent has to do, some documentation maybe on what fault codes mean, which data table to go find the faults. Often we have a template of how we want the data to be reported, and then some example queries. So this will get loaded. You would do a slash, slash command in Claude. So you could do a slash. Here we're going to do load the performance engineering generic kind of skill that will load. I can show you this one quickly. Performance engineer. This is a big skill that has all this context about how data is structured. For example, now we looked at the BSS, the power conversion. All this will be documented into this document. Some example queries explaining where the data is. So this is like, we didn't draft this by hand. You get Claude to draft this with you. There might be a starting point where we have a ERD document with your data structure. But over time, you get actually Claude to draft this for you. And once this is loaded, then you could ask questions. So we could say, how many measurement source for a certain project? And because of the skill, the AI agent is aware of that there is things called measurement sources, and there is projects, and it knows kind of what to query. So you could query what's the equipment availability, what was the energy delivered yesterday, or whatever questions you want to ask on the assets.
Yeah. So you're not just automating like reports to your customers. You're able to like really look at almost real time analytics just through like plain language prompts.
Yeah, it's really like getting the domain expertise from the engineers into, like, they use Claude to help their analysis work, and we're talking about engineers that are not software developers, so they have a very limited understanding of Python or SQL, but they understand deeply the equipment, the problems we have, and they can chat with the LLM that has access to all this data, and they walk through this problem. And sometimes it could take them a few hours to walk through a problem, but once you understand, once you have good results, you could actually ask the LLM to document this, and then that becomes repeatable over time.
Yeah,
and
that's super interesting.
So today we don't like, there's some things like finding certain type of fault. I'm not going to go and build a dashboard and a DBT model to go and find problems and create a report. Like, it will take me almost longer to go do it the old school way, than having the engineers create a skill and then us automate the skill.
Right. How long does it take you to kind of create a skill to get it into production?
Like, it takes it's very quick. So once the skill is done by the engineer, they would just check it into Git.
Sure.
And then we can pull it into Mage. That takes a minute actually to run what ran on the user's computer. To run it into Mage is a matter of minutes.
Yeah.
Because the way we have it set up is like Mage has a copy of the same folder we just ran the skills in, so it can actually pull down the Git repo, the latest updates, and it has access to the same secret manager. That's a key. Now, there's a few complexity with having these two different environments, one on the user's machine, one on the a remote machine. This actually runs in the Docker container. They need to have somewhere to kind of have the access to the same secret. So we use 1Password exclusively to track, to manage all or secrets.
Okay.
So on the user's machine, when you connect to the MCP server, it just prompt you for your credentials. on the remote machine, it'll just have access to those credentials through a service key or something like that.
Yeah, no, that's really interesting. I kind of wanted to ask, when did you realize you could run Claude Code as a sub process inside Mage or inside a Mage block?
So actually, I had been running Mage for various things aside from kind of ETL pipelines. I wanted to really standardize. I like to not have too many tools. So pretty early on, I ran Mage to do DevOps tasks like run like Ansible playbooks and Terraform scripts to manage infrastructure. So I have a dedicated Mage instance that can, through Python subprocess, kind of trigger like I like to use make files. So you could have you could run a make file, a make recipe that goes and do a bunch of curl commands or AWS CLI. So I've been doing this for a while. So when I wanted to automate Claude, I was like, well, I could just run it in Mage as a sub process with a Python kind of block. I kind of wish sometimes that there would be a bash block in Mage, but really I don't know if a bash block would do much more than you would probably do a sub process in the background. So it's pretty straightforward to actually create a Python block that just runs anything really in Mage. And you have, what's kind of neat is you got access to the standard output of the sub process. So then you can log all this into your logs in Mage, and then you can then inspect the output, reprocess it. So it's actually pretty powerful for automation in general.
Yeah, I'll have to bring the bash block up to the engineers to see what they think about it. um, but kind of circling back to your customers, what kinds of battery faults or anomalies, or I guess it's not really circling back to your customers, but really the system in general. What kind of faults or anomalies is the system catching that would have been missed or caught like later, that would have some effects on like your analytics for your customers?
So one of the use case, and we're going to look at this one specifically, is this battery fault root cause, a fault root cause analysis in general. So if you remember, there's like the PCS, the power conversion system, and the batteries. They're all electrically interconnected. And when you have a fault on the PCS, it could have been caused by the battery. It could have been caused, like there's things just gonna trigger each other's to fault. So you end up with, like, in the logs, you got a bunch of faults, but you need to kind of dissect this to figure out like what triggered the fault, and then kind of what happened around the fault. And then so there's something that triggers a bunch of faults, so you can just sort through this to figure out what was the root cause. And then you might have a manual intervention that caused more faults. So you need to kind of ignore those. So it is actually easy for an engineer to do, but it's very time consuming. So we actually have a pretty big skill here that goes through this root cause analysis and really go find the true root cause and analyze everything that occurred at the same time. So maybe there was manual interventions. Also look at maintenance tickets. So there's field technicians that do maintenance that record like their work. The AI agent will also correlate kind of the activities on site at the same time to really find out what caused it, and then report it in a certain way for us so we can really understand what happened. And then what we would do is, like, we will, every fault that we find, we would push into Notion, like into a database, and then we would kind of cross-reference this to make sure to see if there's new faults or if there's faults that are coming, that are kind of repeating themselves, and then bring this up to the engineer to say, hey, it looks like you got this type of fault that's caused by XYZ, and that's occurring quite often, and maybe it's occurring on a certain machine or everywhere around the plant, and that will trigger them to do root cause analysis. So very big skill. This takes like 10 minutes to run for like the agent to to just run queries and go back and forth. So in Mage, it actually looks like, let me just jump into, maybe I'll show you the output first. So the output actually looks like this. We get a daily report
Okay.
with a list of all the faults, like broken down by if they're real fault, if they were maintenance induced or whatever. Like there's lots of different things that could cause the faults, and then an action item list of things that you should really go and inspect. And this, took 6 minutes to run. So like the AI agent went and do a bunch of analysis and dug into different faults. And every day is different. There's different equipment at faults and different faults that come up. So
Sure.
that's a huge time saver. And this email gets sent by Mage. So we have, so here I'm in our Mage analytics kind of instance. So we have multiple instances of Mage, some dedicated to ETL, some dedicated to DevOps. So you could have a dedicated instance of Mage just for your AI agent. That's all it would do. And this is really then a good orchestrator for an AI agent, because you could have a bunch of triggers, what
Right.
triggers the agent, and then you got your logs and a bunch of stuff. Yeah, we use this to run like notebooks, like reports, and then Cloud Code. So on this instance, we have Cloud Code like running on the same instance. And this pipeline is like, it's pretty simple. It's just as one block, one step that pulls down the latest version of a branch, a Git branch of a repo. So that same repo that the user was using on their machine, when you run the pipeline, you don't have to have a CI/CD pipeline that updates this. Like the pipeline itself just pulls it down.
Okay.
So we have the latest and greatest. And then a Python block that runs Cloud Code. We'll take a look at this. And then we save the output into Postgres, and then we email the report.
Yeah, this is awesome.
So there was...
And it looks like a super simple, I know it's not simple, but it looks like a super simple setup here once you've got the skill and everything going on.
This is it's actually quite simple. Now you'll have to like find a way to standardize this so it could run different type of kind of skills and payload. So as long as the output that you're expecting is similar, you could have one pipeline. And here you see we have a bunch of triggers.
Right.
Now, most of these are like reports that we want to email and then we want to store. So this could be like a reporting pipeline. So any skills that's like report style, you could just run in this. You could put an email. So we have each trigger here. So here we have one, for example, that looks at the balancing of the sites. So we have the skill we run and the prompt.
Okay.
And then we select the model we want to run. There's a few different things. There's a timeout. So you can make sure that this thing doesn't go run for like hours. So part of sub process, you can actually control a bit what Cloud Code does. It might control your token budget a little bit. And then maybe some parameters related to what you do. So who you want to email, your email subject, and a few different things. And then each run, then you would have an history of all your runs and then your logs of everything that happens. So that's gonna super useful, but here it was running for a long time. So I'm gonna give you a quick example here. We actually have, this is a quick test where we actually don't run a skill, we just run a prompt. Like there's no skill, so we just ask what's the population of whatever. So actually we can run this in the pipeline editor here. So this block was our git pull. So again, another sub process. Where do I see another sub process where we're gonna just do a git pull.
Okay.
Straightforward. The main block that runs Cloud Code using sub process. We prep all the variables that we want to use. We rebuild like there's a system prompt somewhere there's a system prompt that we append to the main, like the prompt that's in the variable. we just tell it that this is actually an automated pipeline. So it's not like we wanted to a lot of the work in this block is actually to get it to output something consistent enough that we know what to do with. Because that's a bit of the issue is like this large language model is they just like spit out some text and stuff. So you have to kind of some work in this Python file, and this was mostly vibe coded, you know.
Yeah.
So this is fairly easy to develop. There is also option in Claude code specifically to define the way you want the output. If you want it as a JSON payload, let's say you wanted a number out of it, you could actually define a JSON structure where you say I want XYZ. So here, actually, this example, we want the country and the population in this specific format. So this would be aware of it. So here, if we do, we're going to go back to Canada here, where I am. So if we run this, it would just run this prompt here.
Okay.
Now, if we had a scale, it would just load the scale and then run the prompt.
Gotcha.
And then what we did here is the output of, so it's Claude Code will return a JSON output with a bunch of things in it. One is the result, but at the end we kind of reformat everything into a data frame.
Gotcha.
That we're gonna go and store into Postgres, and then that we can also extract for emailing purposes. So in this case, it ran. That's the population of Canada, 38 million. That was a prompt, and then there is like the raw output.
Okay.
From the AI agent, the cost, whatever. So then it's like, then you know, like from there you can do whatever you want with this data. You can export it to a database, test it. In our case, we email it using like or AWS kind of services. So.
Yeah, super interesting. So circling back again to your customers, how much trust do your clients put into these AI generated reports, and are your agents acting on them directly, or is there still like a human review step? How does that kind of work?
Yeah, so today it's still to really support a specific function. So it's really there to help like the performance engineer to just can handle more projects on their own. We don't send this directly to kind of, I don't know, it's not going into a quarterly report of the sort, but it's just it's really used to help make things more efficient. And we closely monitor the output so we can improve the skills. So I think we really have to think of these AI agents like employees almost, where someone has to monitor the output that comes out of an employee, and same with these AI agents. We haven't really had a use case where we do a bit like this population where we get a specific numbers. I think that's an AI problem where the AIs, they drift, and AI models could also change a bit the output. So I think Mage makes it easy for us to monitor the output, test it, but the trust, we'll have to see how reliable these things are, but they're quite useful right off the box here.
Sure. So I know you have a quick demo prepared for us, but I just wanted to let the audience know that we're coming up on, the last parts of this session. And if you would want to go ahead and get your questions in, that'd be great. I know we're on like a minute long delay for LinkedIn and YouTube. So if you want to get those questions in now, we can walk through the demo and then answer them right before we end. But let's go ahead and get into kind of the demo you have prepared for us.
So I could do a quick demo of something unrelated to battery. It's actually a wind wind and wave finder skill that I do like wind sports, and I'd like to
Okay.
know what the wind forecast is going to be. So I created a quick like skill that goes and find the wind speeds, the wind direction, and the waves for a certain spot. I got this is all vibe coded, by the way. Got Claude to kind of write a little Python script that's going to go to an API. So just to show you how you could run this, and you would just run this in Claude to try to get the output. So really, whatever you want to automate, you first develop it on your own, and then I'll show you how you would automate it into Mage.
Okay.
And it's good to run this manually. So you don't want to run everything in Mage from. You almost want to like do it yourself first, so you can explore the output of Claude, so you could see exactly where it's spending time, if it's making if there's errors, because over time you want to improve this. So here in this case, the output looks like this: just a table, the days, the good days to go, kind of wing surfing or boarding. So this is useful, like if you want to run it in your terminal, but it'd be more useful if it landed in my inbox every day. So once you've developed this, you just go to Mage, and here actually it's running in the same pipeline that runs other business things. I think it's here. Yeah, it's right here. So it's just another trigger
Okay.
that you just configure with the same skill. Like we just ran /windfinder, and then actually I didn't even put a prompt, but here it's just
So
give me a
your
forecast.
pipeline is almost the same. You're just using triggers with different runtime variables to kind of segment out your reporting, and for this specific your wind, you know, looking for days that are going to be good for boating or windsurfing.
Exactly. So if like today, if I was doing a air quality like little skill, I could just check that into Git, and here I would just create a new trigger, and then it will just say like wind quality, maybe whatever I call the skill, with a prompt, and that's all I have to do, and it will just run. And this is like designed to run every day at 11 UTC. So then I get an email every day that looks like, oops, that looks like this. And that keeps me motivated,
Yeah.
looking forward to the weekend or something, or maybe not if it's not, but and then we write back to Notion. So you could really, anything that you could do with Claude, you could automate it here. So you almost don't, like, you could get Claude to write back to Postgres or Notion or whatever that Claude can access. So with MCP server, like Claude can really have access to pretty much anything. So
Sure. No, this was super interesting. Is anything else you want to show us on the demo or from Mage?
not really, no. Happy to answer any questions if some come in.
Yeah. So if there are any questions that come in, please go ahead and write them now. But kind of what's next for Librenergy? Are there any other kind of skills you're looking at writing? What's your like future for kind of these autonomous AI agents?
So the kind of next phase of those implementation is really get away from the email. Today we're sending emails, but if someone has to still look at the email, the next step will be to create another agent that go look at the daily reports. So maybe every week we'll have another skill that says go to the Postgres logs of all the reports we run this week, and then further kind of compile a summary of all the problems we had and what we should work on. So just like we get just layering these agents have agents maybe checking. You could have another agent checking the work of another agent, and so if you use Mage to store the output of each agent run into Postgres or whatever database, then on another frequency you can run another agent that goes just read that. You don't have to run the whole study anymore. So it's kind of what's on our kind of to-do list here for the future.
Gotcha. So that's kind of we're kind of wrapping things up. Just if you do have questions, we'll be around for another minute or so. Maybe just we'll chat a little bit. I know Fred's in Canada and I'm right outside Washington D.C. So, but that's it was kind of interesting that you're a windsurfer.
Yeah, so lots of lakes around here, the Great Lakes. So
Yeah, definitely.
and we just it's getting warmer here. It's not so actually was in the water last weekend, so it's getting quite pleasant here.
Yeah, I lived in Michigan for a little bit, so actually 6 years. So definitely familiar with all the Great Lakes from the U.S. side, at least.
And the
But
water is often warmer than it is on the West Coast,
yeah,
So
yeah. Well, I think that's gonna do it for today. Thank you, Fred. It was really awesome. Um, you know, the this video is gonna be like reviewable again on our YouTube channels, and we'll have additional posts from LinkedIn. So I'm hoping that people will get a lot of benefit from this.
Yeah, that's fun. I think the key is Mage can do quite a bit, and instead of using a bunch of different tools, let's try to master one tool that can do your data stuff, your agent orchestration. It's much easier to reason about this one tool in Python, in SQL, than just having a bunch of different things that do.
Yeah,
It's
tools
harder
for
to
all
manage.
can eat into your budget, that's for sure.
Exactly.
But I think that is going to be it. Fred, thanks for joining us.
Yeah, it was my pleasure. Thank you. Have a good day.
Have a good day.